August 2015. The Urania, a research vessel of 1,100 gross tons, was on the keel blocks in the floating dock. It was 188 meters long, 42 meters wide, and with a lifting capacity of 18,500 tons. The weather was calm, and there was no indication that anything could go wrong. But suddenly, it did, and it occurred in the late afternoon when the hull abruptly tilted on its port side, fell from the keel blocks, and collapsed on the floor. In an effort to make the basin accessible to the rescue launches, which immediately came to evacuate the people on board the listing vessel, the dock was ballasted again and left lying on the muddy seabed. Unfortunately and unexpectedly, water came in, causing the pump room of the dock to flood. The day after, the situation was puzzling. The Urania was completely flooded, listing to her port side, and her main deck was about a meter below the sea level. The floating dock was fully ballasted, and none of its equipment and machinery could be used because they were all out of service due to the flooding of the pump rooms. The dock's floor was at a depth of about 8 meters below sea level. The water visibility was usually very poor, never more than a few dozen centimeters. A routine operation was now the scenario of a major casualty, which had to be approached accordingly. This is the story of the raising of the Mediterranean floating dock, carried out at Leghorn, Italy in September 2016.
I began my career in a relatively small shipyard in Italy. The most part of our job was in repairing and conversions. And one of the most fascinating projects was the refitting of a cruise vessel which had sunk in the Baltic. It was salvaged and then towed to Italy to be refurbished. And it was a fascinating job. After a few months, we had the proudness of redelivering the vessel in the Caribbean area. We delivered in Miami. And it was a nice moment in which we saw the new vessel sailing again for her new business. When I was approached by the owners and managers of the disabled dock to prepare a feasibility study, I was aware of the challenges which were behind that project. The asset was an important one, and just the feasibility study showed that it was necessary having to do with different stakeholders. I knew, however, which were the tools to be used because they were not new to me. So I was conscious of the possibilities. The incident has caused dramatic consequences to a number of persons. A major asset in an important port was out of service, and a first-class shipyard had its main launching and hauling facilities completely out of order. The various stakeholders, including the port authorities, all the public prosecutor involved in the matter, was very, very careful in not allowing any type of intervention which was not carefully designed since the beginning. The key point was that nothing was to be left to the case. Everything had to be designed at a very early stage.
The divers of the fire brigade had first surveyed the area using an ROV, but their intervention was targeted mainly to exclude the possibility of an immediate worsening of the situation.
The first aim was obtaining the trust of the authorities. So I put in contact the specialist divers of Carabinieri with the consultant to the public prosecutor. They made the first diving survey in the area. However, unfortunately, this was not fully satisfactory from a technical point of view. They did not reach the level of information that was necessary to prepare any type of design. A small and efficient team reached Leghorn, and the superstructure of the vessel were laser scanned, whilst at the same time, by a multi-beam, we tried to obtain a pattern of the debris under the water by using a sonar. The results were not fully satisfactory, but however they gave some results which were quite important for the following project. The side scan sonar was important to try to find the position which the blocks coming from the original dry docking plan were in the moment. It was necessary knowing where they were because it was not clear if the vessel was stable in such a position. So having repeated diving survey with divers underneath the hull, which was not stable 100% in that position, might have been dangerous. That's why we were really in favor of remote scanning, both with laser and sonar, without involving any person directly close to the object.
The extent of the damage to the dock was unknown, and no detailed assessment was possible.
I witnessed the laser scanning, and when I understood where exactly the vessel was within the dock, I presumed that some of the compartments had not been touched by the falling vessel. So I made a very rough calculation, just to understand if it was possible raising the dock without using the compartments which were likely damaged by the collision. However, these first assumptions have to be confirmed by a more scientific tool. Therefore, I contacted my colleagues of Herbert Engineering that I know since some years ago, let me say 5-6 years ago, which developed a specific software tool for salvage cases such this one.
Herbert Engineering is a consulting company headquartered in Alameda, with offices in Annapolis, Glasgow, Shanghai, and Singapore. One of the services provided is salvage response by using the software HexSalve, developed on purpose in-house.
I had spent a few days in Glasgow together with Luca Letizia, their European manager, and I was conscious that I had the perfect tool and people to support me. Rob did some simulations, and this proved that my first assumptions were correct. It was possible raising again the dock by using only the compartments which most likely had not been touched by the falling vessel. However, the problem in this moment was that we were aware that the pump rooms were completely flooded. All the systems of the dock were out of service. So a different system has to be found to deballast the compartments. I thought therefore to use some deep well pumps to be lowered into the double bottoms through openings to be created by divers on the dock floor.
At this point, the progress of the project was just halfway. A further obligation was given. The vessel was to be stabilized in the dock in order to be sure that no movement was allowed during the refloating operations.
Construction divers are used to utilize wedges, pillars, even sandbags, everything they can invent with their ingenuity to stabilize a floated or sunk vessel. However, this case was pretty different because anything has to be designed, everything has to be proved and scientifically calculated. It was necessary finding a way of demonstrating to the various stakeholders that our system was reliable and safe. Apart from safety of the project, another important issue was minimizing the impact on the forthcoming investigations. It was necessary preserving as much as possible the status of the floor dock and avoiding any unnecessary removal of the object. We used the results of the laser scanning that we did a few weeks before, and by overlaying the cloud of points coming from the laser to the drawings to the actual drawings of the vessel, we created a 3D model which was layered into the dry dock, and it was therefore possible understanding which were the interferences and the exact position of the vessel as it was in that moment. Having done some sonar surveying, we knew at a certain extent which was the position of the interfering objects. So it was possible finding some sections where placing the stabilizing devices, which were to be designed. These sections were very limited in number because in a few places we had the same characteristics of strength and availability of space. Dynamic simulation was run, and it was understood that it was necessary putting some stabilizing blocks on starboard side, whilst on the port side rods were necessary. The vessel had the tendency to move on her starboard side. All these stabilizing devices were designed by using FEA. There was no rule to be followed. We had to use a direct designing approach. So everything was calculated by using the software which is available at the moment.
June 2016. The project is complete and has been submitted to Registro Italiano Navale for cross-checking and then presented to the consultants of all the stakeholders to inform them about the decisions taken. In the matter of a few hours, all the participants are convinced and the green light is given. A temporary working site was created aside the flooded dock, including containers for offices and meeting rooms, a small workshop, and store. Wheeled cranes were moved in, services rerouted to provide compressed air, electricity, and technical gases. Specific measures were adopted to allow the safe participation of surveyors appointed by different parties, however avoiding any possible dangerous interference with the operations.
We established very, very strict safety rules, and it was our firm intention to apply them in a very strict way. Nobody has to be injured in any way during the operations, and there was no incident whatsoever was to be accepted.
In 4 weeks, about 25 tons of steel structures were cut, welded, and prefabricated, each of them in the shape and dimensions imagined on the computer monitors only. The pipes intended to accommodate the pumps into the double bottoms were delivered and the pumps provided. The participants requested to put all of the materials in the exact position were now called on the scene. The next step was to appoint Drafensub, an underwater marine services company. Drafensub was started in 1976 by Adriano Passeri, my father, who is now president of the company. His first introduction to the sea was when he was in the Boy Scouts, at which time he created the sea section because there was no one else. So together with some friends who shared the same love of the sea, they started diving near Portofino, using very basic instruments to reach their goal, to go underwater. Since then, he has used his passion for the sea to create the basis of what would be his life. The team managed to obtain post-war instruments and gear from the Marina Militare underwater department, so the first diving masks were things that my father modified and adapted for his own specific needs. I guess you could call him a pioneer, and along with my sister and brother, we followed him until today, where the company works internationally with all the necessary certifications in places such as Iraq, on the Mosul Dam. As of 5 years ago, we began outsourcing certain aspects of the project. Before that, we were the only participants, but now we plan in advance with our own engineers, which is the best way to complete the job. Meeting Alessio was a kind of a thunderbolt, because when two people combine their job and passion work together, there is obviously an immediate understanding. So when my father met Alessio some years ago, it started what was, and still is, a very good business relationship that makes us work again for the refloating of the Bacino Mediterraneo and the Urania boat. Mr. Gnecco presented us with the project down to the minutest details for the operation that actually went exactly as he had projected. In my life, this had never happened before. I mean, starting a project and executing it without any changes was not something that had ever happened to me. With Alessio, however, it did. We had to follow the strict rules that the judge applied. It meant not moving any object present in the area, and therefore install the saddles that Mr. Gnecco had designed. The divers were equipped with online cameras and microphones in order to receive instructions from the surface more easily. As soon as the position of the saddles was correct, the divers started to weld them to the ocean floor. This was only possible thanks to the special equipment that the divers used in order to work in dark water. The cappuccino effect happens when the water you work in is dark due to oil, chemical materials, and the seawater from the port, which in Livorno is a mix of fresh and salt water, so the diver was not able to see his own hands. It was as if the diver were inside a cappuccino. In this case, the divers have to work from memory. It means that you have to stop trying to see with your eyes, but start using your memory and feelings, as a blind man would do. For example, if you have to weld, you use the touch of your hands to understand where to do the job and to see if it is done well. The working time and time schedule were planned to grant efficiency and fast response without the overstress imposed by an emergency activity. As if it were a crime scene, we could not afford to make even one mistake, not even something as minor as hitting your thumb with a hammer. Everybody was expecting another accident because it was an unstable situation. The mobilization of the team of construction divers required the shifting to Leghorn of a diving support trawler, a fast RIB, and a couple of assisting boats, a dedicated recovery system to retrieve divers in case of an emergency, a hyperbaric chamber, plus all the loose gear which was considered necessary. We made a security plan testing the potential need to recover an injured or unconscious diver from the deep to our hyperbaric chamber or directly to the hospital. The best solution has been using the LARS, the Launch Recovery System. It is basically an elevator which is placed at the worksite from which the diver gets in and out of the water. With this method, there is no diver jumping into the water, and recovery of an unconscious diver is thereby easier and safer. The team was made up of a superintendent, who was the one who decides how to run the daily tasks, and is the one who is in communication with the project engineer. Under the superintendent, there are 2 underwater supervisors, who are in charge of 4 divers each. It means that more than 10 people work together at the same time. Once the boat was secure and we started the refloating part of the project, welding 10 pipes with a diameter of 100 centimeters, installing the 10 water pumps that allowed us to dry and refloat the dock in complete safety. It looks like a magic trick, but it's really the result of perfect project organization. And as I said, it happened to me only once in my entire life. At dawn on September 15, 2016, the pumps were started. The success was complete. After about 9 hours of controlled and sequenced deballasting, the floor of the dock was again above the sea surface. The project required 6 months of designing and projecting, 2 months of preparation, and then the refloating was carried out as scheduled in about 9 hours on September 15, 2016. About 25 tons of stabilizing devices were manufactured and put in position. Almost 200 meters of pipes having the diameter of 1 meter were inserted into the double bottoms. About 1,000 man-hours were spent diving. 16 deep well pumps having the aggregate capacity of almost 5,800 cubic meters per hour were used. Despite the impressive data, if you ask these guys which figures are in their opinion better describing the project, they say 5 and 0. 5 days of delay on a schedule of 44 planned when the project was still to be finalized. 0 accidents.